Hi everyone, so today we're going to finish up this chapter, which is chapter 14. I'm going to quickly remind you where we left off and then we're just going to jump right back in. So what we were talking about last class is perfectly competitive markets, which we said are characterized by having many, almost an infinite number of buyers and sellers. There's free entry and exit, so everyone can just come into the market if they want to, they can leave the market if they want to. Everyone's selling identical products. So it's markets kind of like concrete, where it doesn't matter who's manufacturing it, the product is the same. And the last important feature is that everyone's a price taker in the market. So because everyone is so itty-bitty relative to the size of the whole market, it doesn't matter what they do, their behavior is never going to affect the market price. So the pictures that we were looking at last time helped us to determine how a firm in a market like this should behave. Specifically, if they want to maximize their profit. So the first thing that we said is that firms need to produce the quantity where marginal revenue equals marginal cost. And the reason they want to produce at this particular quantity is because this is the quantity which, according to calculus, will maximize their profit. Okay, the second thing we calculated was what the profit was. So we said a firm's profit is equal to the price they take on the market minus the average total cost times the quantity that they're selling. So we had a couple different cases we looked at. So case one is, let's just suppose this was the price everyone in the market took. And price in perfectly competitive markets are always equal to marginal revenue. And if we've got an upward sloping marginal cost curve and a U-shaped average total cost curve where the bottom of the U intersects with the marginal cost curve, we've got ourselves this kind of situation. So in this setup, what we did is we put ourselves in the shoes of the concrete manufacturer. We said, okay, what he needs to do first, he needs to figure out how much to produce in order to maximize profit. The quantity he's aiming for is a quantity where marginal revenue equals marginal cost. And this graph, this is marginal revenue, this is marginal cost. This crosshair tells us the quantity that he needs to produce. Let's calculate what is his profit when he produces there. Well, price, if he's producing here, is right here. If he's producing right here, average total cost is equivalent to that value. Quantity is here, so price minus average total cost gives you that leg. Quantity gives you that leg. So the area of this shaded region would be equivalent to the profit that the manufacturer, the concrete company owner was making. And since the price is above the average total cost, it's positive profit. So in this case, yeah, it's positive profit because the price is greater than the average total cost. So again, we're always kind of concerned about the relative positions of price and average total cost. Another case we looked at is a case where a firm is making negative profit. The best they can do is to lose money. They could do worse, but best case scenario is still not great. Okay, in that situation, the firm might take a price that's kind of low. So this is just the structure of the market. You can't impact it. The price is low. Price is equal to marginal revenue in perfectly competitive markets. Marginal cost curves generally slope up. And then maybe in this case, the average total cost curve is above the price bar. Okay, so what does the concrete company owner do? One, he sets his production at the Q for marginal revenue equals marginal cost because that's the level of output that he would need to maximize his profit. So marginal revenue is here, marginal cost is here, here's the crosshairs, here's the quantity he's producing. Okay, what is his profit? Well, at this quantity, here's the price, here's the average total cost. So price minus average total cost would be equivalent to this distance but negative. And then quantity is here. So in this situation, the area of this shaded rectangle is equivalent to the negative profit that is being incurred by this firm. And the reason it's negative profit is because in this case, the price is less than the average total cost. Okay, so that's where we left off last class. The question we want to think about now is, well, what is the concrete owner to do? So concrete company owner to do. If he's in this situation, what does he do? And if he's in this situation, what does he do? And how do people who are just outside the company and looking in, what do they do when they see each of these things? Okay, so here is new information. Okay, I'm going to tell you first what you should do, and then I'm going to explain to you why you should do it. So let's frame this as a question. Question: what should the firm do? Okay, there's going to be two things he should, actually three, I'll make it three. There's kind of three possible things he might do. Thing number one is the firm should shut down, and shutting down is going to be a temporary thing, so we're going to say temporarily shut down if the price that he's getting in the market is less than the average variable cost. We haven't really talked too much about variable costs yet, but it's going to be important here. And the reason, I shouldn't draw the arrows too soon, the reason he should shut down if the price is less than the average variable cost is because this implies that implies that, right, this is another way, total revenue is going to be less than variable cost. Okay, let's just do some mental gymnastics here. Okay, first of all, what should the firm do? The firm should temporarily shut down or just kind of suspend producing stuff if the price is less than the average variable cost. Okay, mathematically, one thing you can do to an equation is you can do the same thing to both sides. So let's take this and let's just multiply each side by Q. So if we had a price, multiplied it by Q, then on the other side we'd have average variable cost, we'd have to multiply it by Q. Price times quantity is total revenue. Average variable cost times quantity is variable cost. So what we're saying here, another way of saying this, is the firm should shut down if the amount of money they're bringing in is less than the variable cost. What are variable costs? Variable costs are things that the firm has to pay for based on how much they're manufacturing. So it's kind of like labor. So in other words, the firm should temporarily suspend production if the amount he's bringing in doesn't even cover labor. Okay, that's one thing. What the firm should alternatively do is he should permanently exit the market and let me just emphasize this. In economics, anytime we talk about exiting, this is going to be a permanent decision. Anytime we talk about shutting down, that's going to be a temporary decision. So I could actually leave off the temporary and permanent. It means the same thing, but I just want to emphasize shutting down is always just a temporary decision. Exiting is always a permanent decision. Okay, so back to his decision. The firm owner should permanently exit the market if the price that he's taking is less than the average total cost. Okay, why is this the case? He should exit the market in this case because if the price is less than the average total cost, this implies that the total revenue he's bringing in is less than the total cost that he has to pay to be in business. Okay, again, the reason this is equivalent to this is because you can multiply both of these things by Q. If you take price times quantity, that's total revenue. If you take average total cost times quantity, that's total cost. So intuitively, this makes a lot of sense, right? So it's saying the firm should just like get out of the industry if the amount that he's bringing in doesn't cover all the costs that he has to pay. We also know that when we're looking at profitability, the magnitude of the price relative to the average total cost is super important. And specifically, if the price is less than the average total cost, that meant the firm was making a negative profit. They were losing money. So if this is what characterizes what's going on in the guy's business, then he needs to permanently exit the market. Okay, let me give you pictures of this now so you can see in the graph how this would work. Okay, so again, it's going to be important that these graphs get drawn pretty precisely. So first, let me draw for you the picture of kind of what a shutdown would look like, or when he should shut down. Okay, what we're going to do is we're going to plot price against quantity. Let's suppose, or first of all, let's just kind of put in the big component. So we've got a marginal cost curve that slopes up. We're going to have an average total cost curve that's U-shaped. Bottom of the U is where it intersects with marginal cost. And then one thing we talked about a couple classes ago was that because variable costs are a component of total cost, the average total cost curve is going to be kind of the same shape, but underneath the average total cost curve. So an average variable cost curve is going to get drawn in here. And the way you draw this needs to be such that average variable cost is also U-shaped. And also, the marginal cost curve hits the average variable cost curve at the bottom of the U. Okay, what would a shutdown, or when would a firm want to shut down? Well, we said that the shutdown should happen, so they should shut down if the price is less than the average variable cost. Okay, here's the average variable cost. If the price is right here, for example, if this was the price, a firm would want to shut down. Why would they want to shut down? They would want to shut down because first they would pick the optimal Q. Optimal Q is where marginal revenue equals marginal cost. That's right here. They'd be producing, this would be the amount they should produce, so they want to maximize their profit. If they're producing this quantity, then at this quantity, here's the price, here's the average variable cost. So again, at this quantity, here's the price, here's the average variable cost. The price is underneath the average variable cost. The same would be true if the price happened to be here, or if the price happened to be here, or if the price happened to be here. Because in each of these situations, you get a different Q, and for that Q, the price would be less than the average variable cost. So the kind of the shut down region is going to be any price bar that is underneath the bottom of the average variable cost curve. Okay, another way to say this conversely, if you kind of want to back up and think about this in the opposite direction, is if the price bar is up here, the firm should not shut down. Why? Because if the price bar was here, for example, then marginal revenue would be equal to marginal cost right here. At this quantity, this is the price, and it's greater than the average variable cost. And you only shut down when the price is less than the average variable cost. So the range of prices for which a firm would shut down are all the prices that they might experience that are underneath the bottom of the average variable cost curve. Okay, now let's think about prices where the firm would want to exit the market. Okay, so we're going to plot price against quantity. We're going to put in the blue components again. So we're going to have marginal cost. We're going to have average total cost. We're going to have average variable cost. Okay, now in terms of exiting the market, the firm will exit if the price is less than the average total cost. Okay, here's the average total cost. If the price bar was here, then the price is always less than the average total cost. So in this situation, the firm would set marginal revenue equal to marginal cost. They produce this quantity. At this quantity, here's the price. Here's the average total cost. The price is less than the average total cost, so shut down. That would also be true if the price was here, or if the price was here, or the price was here, or the price was here. So the whole, any price that you might pick where the price bar is underneath the bottom of the average total cost curve is going to be characterized by a situation where the price would be less than the average total cost. And so any prices that are consistent with these red lines that I've drawn would put the firm owner in a situation where they're going to want to exit the market. Okay, so one last thing that I'm going to put up here. Okay, I'm going to redraw this. So redraw also just because repeating this is very helpful for kind of making your brain learn it. So let's draw another shutdown picture. So shutdown picture is you got marginal cost, you got average total cost, you've got average variable cost, and you know that anytime we're underneath the average variable cost, shut down. So this whole region here underneath the average variable cost is a shutdown region. Okay, what that means is if the price is anywhere from here up to here, the firm's not supplying anything, so they're making nothing. If the price is going to be above the bottom of the average variable cost, then in the short run, they'll keep on, they'll stay in business, but they'll just kind of like shut down. So they'll just quit churning things off the conveyor belt, but they won't like sell the business. So if that's the case, then the portion of the marginal cost curve that is above the bottom of the average variable cost curve is going to be consistent with what the firm supplies. Okay, so importantly, the green areas that I've shaded are the short run supply curve for the firm. Okay, let me explain why this is. Because if the price, let's say, is, again, the firm's a price taker, they can't influence the price. Let's just say, hypothetically, the price in the market is here. If the price in the market is here, the firm sets their price equal to their marginal cost. This is their quantity of output. At this quantity of output, here's the price. Here's the average variable cost. They shut down. If they shut down, then that means at that price level that I've drawn, output is going to be 0 because they're temporarily shutting down. Okay, alternatively, if the price had been up here, well, then the marginal revenue would be set equal to the marginal costs to maximize profit. At this high level, the price would be above the average variable cost. The firm would keep on producing at this quantity. So the idea, let's see if I can explain this one more time. Again, the first thing the firm always does, they set marginal revenue equal to marginal cost, and then they assess the situation. If in that situation the price is less than the average variable cost, they just say shut down. And so then they're going to kind of move from the optimal Q down to 0 because they know that the best I can do is to definitely make negative profits. I'm just going to not make anything. I'm just going to temporarily shut down. Okay, so what that gives us is a supply that is equivalent to the marginal cost curve for the range of the marginal cost curve that's above the bottom of the average variable cost curve. Okay, now let's think about exiting. So again, draw this with me one more time. So for the exiting decision, what we've got is we've got a marginal cost curve. We've got an average total cost curve that's a U. We've got an average variable cost curve that's a U. And we said a firm exits anytime the price bar is underneath the average total cost. So here's average total cost. So anytime the price bar is underneath there, they exit, or they exit. So that means they just say, forget it. Like, I'm entirely getting out of this industry. Not only am I going to suspend production, but I'm going to sell my factory. I'm going to liquidate and just get out of town. Okay, what that means is if the price bar is anywhere in this region, then they're exiting. And so if they're exiting, that means their output is going to be 0. If the price is above the average total cost, they're not going to exit the market. And then in that case, they produce where they keep on staying in business. And when you stay in business, you produce where marginal revenue equals marginal cost. And so if the price bar is up here, they produce where marginal revenue equals marginal cost. That would be their quantity. So the portion of the marginal cost curve that sits above the average total cost curve is going to be equivalent to a firm's long-run supply. So long-run supply curve is the green portion. Again, if the price is anywhere less than the minimum average total cost, they just exit the market. They say, the best I could do, that Q star would make me lose money. I'm just going to leave town. If the price bar is above that, then I'm going to keep on staying in business and manufacture marginal revenue equals marginal cost. That gets me back up on the marginal cost curve. Okay, now the last part of the story. So the last part of the story is, let's think about, so right now we've kind of been implicitly thinking about a single concrete company. But remember that single concrete company, they're just one component of this huge market. So we're in a perfectly competitive situation where in the concrete market, there's tons and tons and tons of itty-bitty concrete companies. Or concrete companies are itty-bitty relative to the size of the whole market. Okay. So what that means is eventually we're going to have kind of like the market that's going to influence the individual companies. So what we're going to do here is we're going to draw side by side the market and then this little individual concrete company that we're thinking about, and let's think about how the market would influence the company. So over here, let's label this graph the market. And then let's label this graph the individual firm. FIRM. Okay, so we're plotting price against quantity. Okay. Start with the big market. So in the concrete market, so again, the market is just the compilation of a whole bunch of firms. In the market, there's going to be an overall supply of concrete. There's going to be an overall demand for concrete. This equilibrium is going to be the price on the market. All the individual firms take the market price because they're price takers. So wherever this crosshair lines up, you take that price, you bring it over to the individual firm, and they just take it. So this individual firm, they can produce whatever quantity they want. They're not going to budge the market price because the market price was set in the market. Okay, let's suppose we're in a situation where this individual firm, they've got a marginal cost curve. They've got an average total cost curve, and let's just say to start with that the average total cost curve is underneath the price equals marginal revenue bar. Okay, what's going to happen? This individual firm is going to, first of all, say, what number of units do I need to produce so that I maximize my profit? The number of units I would need to produce to maximize my profit is the number of units where the marginal revenue equals the marginal cost. So right here, this would be like my Q star. Okay, the firm owner looks at the situation now. He says, okay, well, if I produce this number of units, here's going to be my price. Here's going to be the average cost of making average total cost of making each unit. This is going to be the positive profit that I'm going to have. Okay. If each firm is selling an identical product, and a whole bunch of firms are making positive profit, then think about the market. So recall one of the defining characteristics of perfectly competitive markets is that there's free entry and exit to the market. So if in this market all the concrete companies are making money, then what you might anticipate happening is that people would say, I want to open up a concrete shop too because they're making positive profit. Okay, if you have people jumping into the concrete market and becoming suppliers because there's positive profit, then think about how that would affect the supply in the market. Well, if more people are becoming suppliers, then supply would increase. A supply increasing corresponds to the supply curve shifting to the right. So it'd be like supply prime. If the supply shifts to the right, then you move from this crosshair down to this crosshair. So this would be the second price. The individual firms are going to have to respond. So if this is the new equilibrium price in the market, that means that these firms are going to have to just take the new equilibrium price. So this new equilibrium price in the market is going to carry over here, and all the firms over here are just going to take it. It's like price bar equals marginal revenue bar prime. Okay, this changes the game entirely, right? Because, and specifically the way that I've drawn this is that when the supply curve shifts over, the new equilibrium is going to get us to a price that's at the bottom of the average total cost curve. Okay, think about how this changes the game. Now, the individual firms, they're no longer playing with this price bar because the market has shifted. They have to take the new price. So the firm owner says, okay, what do I need to do now to maximize my profit? Well, I need to still take marginal revenue equal to marginal cost. Here's marginal revenue, here's marginal cost. So I need to actually change my production level to this amount. Okay, if they change their production level to this amount, then at this quantity, well, here's the price bar. Here's also the average total cost. And so if price is equal to average total cost, there's no longer any profit. It's a zero profit game in this situation. Okay, so what this does is this demonstrates that any positive profit that a firm is making in the short run, eventually it's going to shrink down to zero because anytime there's positive profit, more suppliers are going to jump in the market. That's going to cause the equilibrium market price to fall. The price bar will fall. And in the long run, it's going to fall down to the bottom of the average total cost curve. So each individual firm, there's going to be more total firms, but each individual firm is going to lower its output. And then at that new optimal quantity, all the profits are shrinked up. They've dried up. So now they have a price equal to average total cost, and there's no longer any profit. Okay, let's think about another situation. Okay. Again, repetition helps here, so this will be good for you. Okay, so suppose we've got a market, and we've got an individual firm, and we're plotting price against quantity. And in the market, we've got a supply up here, we've got a demand here, and this is the equilibrium in the market. And because we're in a perfectly competitive market, all the individual firms, they're just stuck with whatever the price is. So we take this price that's determined by the market, we bring it over to the individual firm, and we say, okay, you take it. And so they take the price, and this is also equal to their marginal revenue. Now let's think about a situation where we got a marginal cost curve here, and let's suppose the average total cost curve, which is a U-shaped curve, is above the market price. Okay, what would happen? The first thing is that the concrete owner would say, okay, what is the quantity I need to produce to maximize my profit? Well, I produce the quantity where marginal revenue equals marginal cost. That's right here. Therefore, this is the quantity that will maximize my profit. But he says, okay, let's assess the situation here. If I produce this quantity, then at this level of production, here's my price. Here's my average total cost. Like, this is bad news because I'm in the shutdown region. And so when the firm realizes this, when he realizes that this is a negative profit, he's gonna say, you know what? Like, if this is the best that I can do, I'm just gonna shut down. Like, I'm gonna exit the market. And so he's gonna just say, forget it. He's gonna produce zero because he knows he's making a negative profit. Okay, think about what would happen if a whole bunch of firms are realizing that they're making negative profit and they're exiting the market. Well, if a whole bunch of firms start exiting the market, then in the market, the supply is going to fall, and if the supply falls, then the supply curve is going to shift left. Okay, if the supply curve shifts left, then what that means is that in the market, the equilibrium moves from here up to this crosshair. And so this becomes the new market price. Okay, if this is the new price in the market, then all the individual firms who are left, some of them have exited, but the remaining firms that are left, they have to take this new equilibrium price. So wherever this particular price resides, you bring it in, you bring it over, and you draw a new price bar there. And you say, okay, people are in this market. This is the price you're now going to sell your units at. This is the marginal revenue you're going to get for each unit that you sell. This is the game changer again, right? Because now the individual firms, they say, okay, we're no longer working with this price bar. Now we're working with the green price bar. Okay, if we're working with the green price bar, what do we need to do to maximize our profit? Well, they do what they always have done. They take their marginal revenue, they figure out where it's equal to marginal cost, and they say that's the quantity that would maximize my profit if I'm choosing to produce. So marginal revenue is here, marginal cost is here. So this crosshair gives you their new optimal quantity. And then they say, okay, this is the quantity that would maximize my profit. Let's see what my profit is now. So at this quantity, you go up. This is the price. You go up. That's also the average total cost. And so at this quantity, if price is equal to average total cost, then that means profit is zero. So we kind of changed the story, right? Because previously profit was negative, but after some firms exited the market and the supply curve shifted back and the prices floated up, the profit went from being negative to the profit being zero. Okay, the reason I'm illustrating this is because the tendency of perfectly competitive markets is to always move to this convergent where profits become zero eventually. So the idea is each firm is initially figuring out their quantity. the maximized profit. That's based on marginal revenue equals marginal cost. They then assess the situation. They say, if at that quantity, the price is less than average total cost, I'm leaving the market. If enough firms leave, the supply shifts back, the prices float up, and that negative profit dries up to no profit at all. Conversely, if you have a firm and they are trying to figure out their optimal quantity, they figure out an optimal quantity, and at that quantity, price is above average total cost, they say, great, I'm making positive profit, I'm staying in the market. But if there's positive profit in the market, more suppliers jump in the market. This market supply will shift right. That lowers the market price. The price bar sinks. Whatever positive profits there were, they dry up and shrink to zero. So we're always going to converge to this spot where in the long run, there's going to be zero economic profits. Okay, so let me write this out. So, in perfectly competitive markets, there is zero economic profit in the long run. The reason I'm saying economic profit is because economic profit includes implicit costs, which accountants again don't think about. So in the long run, in perfectly competitive markets, whatever overall economic profit there was, whether it's positive or negative, it's always going to converge down to zero. Okay, so let me write out just a couple notes so that you can make sure that this is in your notebook while you're studying, and then we'll break. Find a marker that works. That is not one that works. Okay. Okay, so kind of summary here. Summary. Okay, first thing. Firms look at the quantity they would need to produce to maximize profit. That quantity is always going to exist where their marginal revenue equals their marginal cost. Okay. If I'm going to call this Q star. So if at the quantity where they're maximizing their profit, the price is greater than the average total cost, then they're earning a positive profit. If they're making a positive profit, then some new suppliers are going to enter the market, because new suppliers are going to, or people are going to say, hey, there's money to be made in that market, we're going to join. So if at the profit maximizing quantity, the price is greater than the average total cost, there's going to be positive profit for the firm. More firms will enter. The market supply will shift right. Market price will fall, and all profit will dry up to zero. Okay, that's one situation. 3. If instead, at the profit maximizing quantity, the price is less than the average total cost, then that means that each firm is making a negative profit. And again, the magnitude of the negative profit is equivalent to that rectangle that we calculated. So if the price is less than the average total cost, then some firms will exit the market. And recall, exiting is a permanent decision, like we're shutting down entirely. If some firms exit the market, then the market supply will shift left and the market equilibrium price will rise. Okay, if the market equilibrium price rises, then that means that the new crosshairs on this kind of left picture float up. The individual firms, they have to take that higher price. So you take that new higher equilibrium price, you draw a new price bar over for the individual firms that's higher. And then if you have that higher price bar, then all negative profits will disappear eventually, so that profit again settles at zero. Sometimes there's some like iterative rounds of this, so sometimes the price will go down a little, or sometimes it'll go up by a little, and then the market has to adjust. But these things, they just kind of keep on going and going and going until all the positive profit dries up to zero, all the negative profit evaporates and becomes to zero. And eventually, this will be, I guess, the last point. Eventually, perfectly competitive markets settle at a profit of zero for the individual firm. Okay, lots of moving gears today. If you have questions about this, let me know. I'm going to emphasize repetition will really, really help as you're learning this. So take the little graphs that I've drawn, specifically the graph with the two graphs with the market and the individual firm. Draw them, make a initial equilibrium, figure out what would happen, change the equilibrium, figure out what would happen, and just like do it over and over again. And that is like one of the only ways you're going to learn how to do this. Everyone who takes Principles of Microeconomics knows that this is tricky, and about the only way you can learn it is just to kind of pound it into your head. That said, if you need help getting it into your head, let me know in the next 10 minutes, and then we'll meet back and practice it a little bit. so it's time to put all your brains to work. What I'm going to show you on this screen and in Blackboard are 3 different pictures. There's one picture for each question. So the picture will correspond to the graph for an individual firm. Recall we looked at a graph for a market and a graph for an individual firm. I'm going to give you pictures for the individual firm. Okay, what I would like you to do is for picture number 1, which is question number 1, first of all answer part A, should that firm, given their scenario, shut down or exit the market? Maybe the answer is they should shut down, maybe the answer is they should exit, maybe the answer is they should do neither one. So tell me what the firm should do. Part B then is tell me, given your answer to part A, what will be the effect on the market supply? So recall the market has its own separate graph that looks like a regular supply and demand curve. And then the market supply curve either shifts right or shifts left depending on whether firms are entering the market, which they will if there's positive profit, leaving the market, which they'll do if there's negative profit. So I want you to tell me, in the market, will the supply curve shift right or shift left? And then part 3 is I would like you to tell me, given the change in supply, what will be the effect on the equilibrium price of the market? So the idea is if in the market, this market supply curve, if in the market, the market supply curve, demand supply, if the market supply curve shifts left, then what happens? The equilibrium price goes up. If in the market, the supply curve shifts right, then what happens? The equilibrium price goes down. And then as a result, the individual firm will have to take a higher price or have to take a lower price. So again, it'll make more sense once you actually see the screen, but there's going to be 3 pictures. For each picture, answer A, B, and C. And then you'll be good. So, we're last kind of unfriendly announcement. We're really winding down the semester, which is great. But what that means is you really need to be on top of the readings because anything you miss, there's not going to be a lot of time to go back and catch up. So next class, we're going to be jumping into chapter 15. Make sure you actually read chapter 15, and this will kind of help you be prepared for class. So on your own, having bad times with markers today. On your own, read chapter 15 for next class. It's about monopolies, so kind of interesting, chapter 15. And that will get you up to speed for the lecture. Again, if you have questions about this, let me know, and I'll try to be super responsive to email and answer it that way, or happy to set up a Zoom meeting if that would be more helpful. So good luck on this, and I'll see you back next class.